Hello, welcome back. In this part we are going to take a look at the ternary operator, which is that question mark, the question mark. This one is called the ternary operator. Okay, this one here. Okay, it's the ternary operator. Okay, so again, the best way to learn is by doing. Therefore, we will go through a mini example to explain the ternary operator. Okay, so consider this, follow this this C code here. Okay, as you can see here, we have our main function and we have some arguments, argc and then argv. Okay, like that, and then we'll return argv, argc. If argc is greater than 1, then we are going to return 5. Otherwise, well, where we use this semicolon, otherwise else will return 0. Okay, like that. Okay, so for those who don't know what C, who don't know how to program in C, you can go back and refer to my tutorial. The link is in the description. I told you from the start you need some C knowledge. Okay, C or C++ knowledge. Okay, in order to follow to follow me. Okay, in order to follow this tutorial. Okay, so and even some assembly language. Okay, so let's take this one. When we compile it using CR, we are going to produce this assembly listing. Let me cross and then I bring it here. Okay, I bring that assembly listing right there. Okay, so here on line 2, which is this one, on line 2 we set up the line 2 sets up a stack frame. Okay, and line 4 is a standard exit sequence, as you can see here. Okay, so there are no local variables. Okay, so it's clear that line 3 is where we want to look. Okay, right here. Okay, so the instruction XOR, XOR EAX simply sets EAX to 0. Okay, and for more information on that line, we you will take a look at another part. Okay, which is about unintuitive instructions. Okay, so the CMP instruction tests the condition of the ternary operator. Okay, tests the condition of the ternary operator. Okay, so the settle function. The settle function, this one here, the settle function is one of a set of x86 functions that works like a conditional move. Okay, so AL, a conditional move. Okay, so AL gets the value of 1. Okay, if argc is less than or equals to 1. Okay, so isn't that the exact opposite of what we wanted? Yeah, it is. Okay, so in this case it is. Okay, so let's look at what happens when argc equals to 0. Okay, so AL gets the value 1. Okay, if argc equals to 0. Okay, so and AL is incremented. Okay, so like that. So if AL equals to 0, okay, if AL equals to 0, then AL is decremented. Note, so if argc equals to 0, AL gets the value of 1. Okay, so it's incremented. Okay, and then EAX is logically ended with 5. Okay, and 5 and 0 equals to 0. Okay, right there. Okay, so 5 and 0 equals to 0. So when argc equals to 2, which means it's greater than 1, the settle instruction, this one here, doesn't do anything. Okay, and EAX still is 0. Okay, so EAX is then decremented. Okay, which means that EAX is now equals to -1. Okay, and what is -1? Okay, so in x86 processors, negative numbers, okay, are stored in 2's complement format. Okay, so for instance, let's take a look at this C code right here. Okay, it's not that one. It's okay. Even it's not that one. Okay, let me bring it. So it's right here. Okay, it's this one here. Okay, It's this one here. As you can see, we have byte x and x equals a -1. Okay, so at the end of this C code, x will be will have the value 1111111. Okay, all ones. Okay, and when argc is greater than 1, sets AL to 0. Okay, and decrementing this value sets every bit in EAX to a logical 1. Okay, now when we perform the logical AND function, we are going to get this one here. We are going to get this one here, and as you can see, these bits here, 101 in is 5. Okay, so 101 is 5 in binary. Okay, like that. Okay, like that. So EAX gets the value 5. Okay, and in this case it's a roundabout, okay, method of doing it. Okay, but as a reverser, this is the stuff, okay, you need to worry about. Okay, so for reference, let's take a look at this GCC assembly output, okay, of the same ternary operator. Okay, so let's take a look at it. It's right here, this one here. Okay, this one there. Okay, that one there. Okay, so you should notice that GCC produces slightly different code than CL, okay, produces. Okay, so however, the stack frame is set up the same way. As you can see here, we push L, EBP, and then we move L, then EBP into ESP into EBP, like that. Okay, like that. Okay, so here you should notice also that GCC doesn't give us the line numbers. Okay, as you can see here, there are no line numbers. Okay, or other hints in the code. Okay, there are no. Okay, we don't have any hints. Okay, so the ternary operator line occurs after the instruction call, this one, underscore main. Okay, and let's highlight that section. Okay, let's highlight it here. Okay, right here. Okay, so as you can see here, we have XO, then EDX, like that. Okay, so again, XO is used to set EDX to 0 quickly. Okay, and AGC is tested against 2. Okay, AGC is tested against 2 instead of 1. Okay, and DL is set DL is set if AGC is greater than okay, they is greater than or equal to. Okay, and if DL gets set to 1, the LEA, which is the load effective address L instruction, directly thereafter will move the value of 5 into EAX. Okay, so because LEA, which means EDX4, means that EDX plus EDX times 4, that is to say EDX times 5. Okay, it's the same. Okay, so like that. So in the next part, we shall take a look at some branch examples. Okay, we shall take a look at those examples.